Okay, sorry about that. I had to step away for a moment. So here we are. We're looking at hatch commands. I can modify the radius of this circle. And as long as the hatch is still interfering and playing with, as it were, the objects that originally created that hatch, then every one of these edits will continue to function just perfectly fine. It's when the elements that make up the boundary change in number is when things start getting a little strange. Like if I wanted to take this and see what happens when I bring this up here. You see how that changed a little differently than we really anticipated? Again, AutoCAD tries to be helpful, but it can't always do what we want it to do. So if I take this down to here, you can see because the number of objects for the boundary, for that flood tool boundary, changed, then AutoCAD cannot keep up with the edits in the hatch. And it's some basic, you'll learn how these things work and how they don't operate as time goes by. I'm going to go back and create a different type of hatch now. H at the command prompt, push the space bar. Now I can use some of these patterns and I can control the scale of these patterns. I come back up here and I want that to be twice as big as it was before. I can even come by and say I want this to be at an angle. Let's make it a nice, even pretty angle, 45 degrees. Now I can do these things, but there's no real world unit that these hatch patterns, that most of these hatch patterns are associated with. Oh, you'll even notice as I mouse over the various patterns that the pattern preview itself will change. And these are not the only options that I have. If I click on this little button right here, you'll see I have quite a few to select from. We even have some brick patterns in here, architecturally speaking. However, I've drawn things so small that I can't really see any of these brick patterns. So it doesn't make a whole lot of sense for some of these. Base box pattern, indication for brass, again, brickwork, and some of these patterns are going to be so, the way that scale works on some of these patterns is not as consistent as we would like. You want to do MC Escher, there you go. You can see there's quite a few patterns that get in here. I'm going to do a honeycomb pattern, and I want to change the scale to 3 times what the scale is defined as. And unfortunately, there's no way to really understand and know what scale some of these patterns are drawn at. So I'm done with this particular pattern, and I want to come back. I want to create a different hatch pattern. This is the one that in my mind is probably one of the most helpful. If I come down instead of pattern, I'm going to say user defined. Now, user defined, the easiest way to think of that is it's going to create a series of parallel lines at a distance that you, the user, are going to specify. So in this case, it's going to draw parallel lines along a 45-degree angle that are 2 inches apart. And I'm just going to pick her right in there. And 2 inches, at the scale we're currently working at, 2 inches seems to be a bit sparse. So I'll make that 1 inch. Let's make it even smaller. Make it 0.5 inches, 0.5, a half inch. But what if I want a crosshatch pattern? I come down here to properties and I say double it. And it will instantly make a crosshatch pattern. For me personally, this is a much more friendly way to make a crosshatch pattern, because this scale factor is the actual number of units those lines are apart from one another. So at 0.5 for a user hatch, those lines are actually half an inch apart from each other. If I'm going to close that hatch creation, I'm going to make another hatch creation. And I'm going to say it's not user defined, but it's an actual pattern. Then I can scroll my way back up to the top. Is it 37? Yeah, there it is, ANSI 37. I happen to know ANSI 37 is a crosshatch pattern, but you notice it's 0.5 what? I don't know what that distance is. I mean, I should be able to tell and work my way around it. 1, 2, 3, 4, 5, 6, 7. Okay, so that's 8 lines across is half an inch. So it's a 32nd of an inch, or a 16th of an inch across, rather. So sometimes that can come in real handy when you're working on incredibly small, detailed information. It may not come in handy when you're doing very, very large scale plans. And you can tell, I mean, at this distance, that hatch pattern is almost solid. You print this out even on a laser jet at 600 dpi, and this pattern and this pattern on the page are going to be indistinguishable. It's usually why I don't use that type of a pattern very often. I will use a user-defined hatch pattern like I've got right here. Now, the one thing that we have left on this panel is a gradient. I'm not going to cover boundaries. Boundaries are a slightly different, they're a slightly, well, they'll be easy enough to show. I'll go ahead and cover them here in a moment. I'll create a gradient. Most of you are familiar with gradients. These colors are pre-selected. They're just the defaults that come out of the box. I can use any of these colors here, or if I click down and say more colors, I've got my true color picker that most of you should be familiar with. Now this little thing right here that says index color, this is AutoCAD's stock palette of colors that have been around for decades now. You'll be seeing a lot more of these colors in future lessons. And why they chose to change it, I'm not entirely certain. I don't know why they chose, because this is not a color. This is definitely not a standard AutoCAD color palette. Every one of these are true color. These, it says index colors. These are the more common colors that we would actually use in AutoCAD. But for now, since we're doing nice, pretty gradients and things are happy, I'm going to select some. I'm just going to select some colors here. And we'll click on that and close. And there we are. We have some gradients that we've included in there. Now a boundary, okay, hang on, let me back up. Remember how I said if we modify these too much or in a different way, it will actually break the associativity that we have within the pattern. You can see as I'm modifying these elements, I'm modifying these lines and these polylines, that the hatches are more or less keeping up with all the changes that I make until I actually move these to a point where they break the number of boundaries. There we go. So I get this line and just bring it up through here, and you'll notice I've got 3 broken elements here. 3 broken hatch patterns, 4 actually. Now you'll notice I've got perimeter lines. I can, using any one of these objects, come back and manually edit these hatch patterns, just as I would manually edit a polyline. They're the exact same options you see. I can stretch a vertex, add a vertex, remove a vertex. I can come to this midpoint, highlight the midpoint, and I can even add a vertex or convert it to an arc. So I can make these modifications if I wanted to. It's just another way of being able to modify these elements. So I'm going to undo all this information until I get these back the way I wanted them, or the way they were in the beginning. Another option that we have here is a boundary. All a boundary does, it will allow you to pick points and create a polyline, a single polyline that is the closed shape that you created. So if I highlight over here, I actually have a polyline here that I can use that represents this shape. And it's incredibly handy because there are tools that we can use in AutoCAD, and I will bring one of these up now. bring up the properties of this particular element, and I can actually find out there's vertices, vertex data associated with it. It says it's a polyline. Okay, it's going to be down here then. There we go. There's an area of my polyline, 39.2296 units. I have a length or a perimeter length. And as I modify this, and this is something that kind of been plaguing me as I've been doing these videos. You'll notice now that my area has been modified since I modified this actual element. But those of you using parallels, there is a slight hiccup in tracking mouse movement because AutoCAD has got its own, there's a fancy term for it, but AutoCAD handles mouse input-output a little bit differently than Windows does. Well, we're running Windows as a program, so Windows is getting its mouse tracking movements from the Macintosh side. So from going from the Macintosh to the Windows into AutoCAD, there's a little bit of glitchiness that happens. It's one of the downsides of using parallels in AutoCAD on just to let you guys know. Okay, so that's a boundary. One of the things that's handy about using a boundary, like I said, is you can use it to calculate areas and square footages, and comes in real handy. Also, if you want to create a boundary, you can also hatch. Bring that up again. Instead of picking points, you can select an object to create a hatch with. And I'm going to do a gradient, and I'm going to select some different colors just so that you can see what's going on. So I can select this object as my boundary instead of using a flood tool or like a paint bucket. So that way I can draw exactly what it is that I'm filling in, which might be different than what I can select in a flood tool. For example, as you can see right here, my pattern goes past this particular line, this arc, and it's still one piece. And I can edit this arc without worrying about breaking the hatch pattern, or at least breaking this blue gradient pattern. It's not going to do that. Another thing that we can do is if I select on this object, if I right click, I now have a context menu of all kinds of things that I can do here. Now, move, copy, rotate, all that stuff, we'll get into in another series of videos, but I did want to show this to you. Draw order, I can take that hatch pattern and I can send it to the back so that all my line work shows up on top of it. It's kind of a subtle thing, and we don't get into it a whole lot, but it does show up from time to time. So those are some of the basics. That's most everything here under the draw menu. As you can see, there are some additional elements. Most along this bottom row are going to be 3D commands. There's some NURBS, non-rational splines that are being done here. There's construction lines and rays, multiple point objects. Truthfully, I'm not even entirely certain what some of these, divide and measure, I know what those do. I haven't dealt with most of these a whole lot. But I will show you guys X-rays or rays and X-lines. And these are just construction objects. They're great for when you want to establish a line that goes from infinity to infinity. We'll draw, take another X line, and it will assume that you're creating X lines as many times as you click. It can be handy when you know you're drawing things, you're projecting down elevations, you're drawing wall sections, and you need to start with something that you know. We'll get into further examples of how this is useful, but that's an X line, and we come across here. The next object is a ray. By the way, X line is XL at the command line, and you can see how people can use X lines to lay out walls, and that's what creates a line of infinite length. A ray is a similar, but it starts at a known point and then expands into infinity. In this case, they're using it to define stair treads along a circular stair. So very similar, except you're only moving off in one direction instead of both directions. I do use these both. I use rays more than I use X lines, but I do that for projecting out elevations, and it turns out it's a very, very handy, very handy, useful tool. There we go. Okay, so there's my 1980s album art. I'll leave that up, and that's everything on draw. The next series of videos we're going to be discussing in the modify command, and hopefully I'll have this information up before too much longer. So hopefully you don't have to wait too long to begin reviewing this information. So thanks everyone for tuning in, and we'll see you guys in class.